Hello folks, I'm Trev Makes It Easy, the channel where we make learning easy. In this series, Trev on Econ, I'll be taking you through topics you're likely to run into in any introductory course in economics at the college or university level. My goal is to make economics less scary, more approachable, and, if I can, mildly enjoyable. With that being said, let's make it easy. Hello everybody and welcome back to another lesson. Today we're going to be dealing with another micro topic, and this is elasticity. Now, we briefly mentioned this in either the last video or the video before this, and we equated it to the term sensitivity. Elasticity is just that. It's a measure of sensitivity, but with an economic spin on it. So the first question is obviously, what is elasticity? Right? And in very plain English, what this is how much we change our quantities, bought or sold, okay, so whether it's quantity demanded, quantity supplied, when price changes. We already know that when price changes, the amount we want to sell and the amount we want to buy changes as well, right? That was what all of demand and supply was about. But one thing we never really talked about was how much does it change? And that's really what elasticity is here to answer. We know directionally where it's going to go. Now we need to add the magnitude of how much is it going to change by. In general, you can think of this as how sensitive we are to price changes. Okay, so certain things in our world, when the price changes, we buy a lot more or less. Sometimes when the price changes, we buy only a little more or a little less. And what the next couple of videos are going to be about is exactly why does that happen? Why do we end up in this scenario where some goods we are more sensitive to when price changes, and then there's others where we really don't care, and it might be by our own choice, or sometimes we just can't afford to care in certain situations. Now, we're going to start this video off by basically going through sort of the basics of elasticity, but we're going to spend the majority dealing with calculations. Now, the reason I would do this is because this is one of those chapters in micro, especially at the intro level, that is more math heavy. The math isn't hard, which is nice. But if your math is not your strong skill, this chapter can feel a little overwhelming. All right, so I want to really focus on that today, and then the next couple of videos will basically deal with the theory side of elasticity, what the different numbers mean, how we interpret them, how we can kind of guess whether something is going to be sensitive or insensitive. All right, and we're going to basically go from there. So before we get too far ahead of ourselves, let's basically talk about the two sort of main camps. Okay, something can be elastic or something can be inelastic. These are the two broadest categories. There's some very special cases we'll see in the next video, but for now, I want to at least get the basics down. Elastic just means that the quantity changes by more than the price changes. So for example, if price goes up by 2%, quantity demanded would go down by more than 2%. Or if price goes up by 2%, quantity supplied would go up by more than 2%. So the direction doesn't change between elastic and inelastic. It's still whatever demand would do with price, whatever supply would do with price. The big change is, again, how much. And again, this is the one you can think of as we are sensitive to the price. On the other hand, there are certain things that we're not super sensitive about, all right? And these things are where the quantity changes by less than the price changes. We are insensitive to the price change. Ooh, not bold. And again, these are just the broadest categories. There's definitely some special cases we'll talk about in a later video, but most things we discuss are going to be elastic or inelastic. All right. Now, it could also depend on the person. This is a pretty subjective idea. What I might be sensitive to, you might not be sensitive to, and vice versa. So again, we're going to think of this on kind of an aggregate level, like in our economy, what is sort of the like average response to these kinds of things. Now, before we get into the math, we're going to start out with a few kind of warnings. If I can spell warnings. Okay. Number one, elasticity looks like slope, but they are not the same thing. Okay? When we talk about the formula for elasticity, you're going to maybe think to yourself, oh, that looks a lot like the formula for slope. And it does. There's some key differences, and how we measure it in more complex scenarios is also quite different. So it's important to know that, yes, they might look the same, but they're not the same thing. So rules about slope, for example, if a slope is like this, we know it's constant all the way through. Elasticity doesn't have that property. A slope might be the same all the way through on this line, but on this line, elasticity might be different at every single spot. All right, so similar, but completely different. Okay, do not mix the two up. It's a pretty common thing I see. The other big one is elasticity has no units. This is another one that tends to get people because elasticity just is a number. Okay, we're going to calculate things and it's going to come out to something like, negative 2.3. And your question is going to be, well, negative 2.3 what? And my answer is nothing, just negative 2.3. All right. We actually use elasticity to strip out the units because it allows us to compare across multiple things. If it was in like dollars, we could maybe compare it. If it was in like quantity, we couldn't compare it, right? What's 2.3 cars to 1.2 apples, right? Doesn't make any sense. So by stripping out the units, I just have raw numbers, and I know that the number 2 is bigger than 1. I know the number 3 is bigger than negative 1. I can compare that way. So just a couple little things to watch out for. Now, we're going to spend most of our time talking about elasticity of demand. Okay, it's more commonly referred to its whole name, which is price elasticity of demand. I have a short form I like to use. But unlike other chapters, it's not going to be 50-50 with demand and supply. We're going to do like 80 to 90% on demand, and then there's a teeny tiny bit of supply kind of sprinkled throughout and at the very end because of specific reasons. Supply and sellers and producers behave a little differently with prices than maybe buyers do. Buyers have a more complex relationship. All right, so we want to spend more time analyzing that. So with that being said, let's talk about our formula. So our formula is the price elasticity of demand is equal to the percentage change in quantity demanded divided by the percentage change in price. Okay. Already, depends on your math skill. You might start to notice why I said this looks like slope, but it isn't. If I had erased the word percentage and just had change in quantity demand over change in price, that would be slope. That addition of the word percentage change instead of just change, that is what makes a world of difference. Okay. Now, like I said, I'm lazy. I don't want to write this out every time. I tend to just write ED is equal to, let's see if I can remember this. Nope. Change. I used to remember the alt code for a triangle. So percent change in QD over percent change in P. Now, again, we might have talked about this before, but the triangle is delta, and it is just a math symbol that basically means change. Right? Nothing particularly special about it. That kind of looks like not percentage. There we go. Not particularly special. It's just a good way to, again, summarize this formula into symbols, which is what we're more likely to see in general economics. All right. So it's a percent change over percent change. The variables that we take a percent change of, that dictates the name of the elasticity. So this is price elasticity of demand. So it has price and quantity demanded. You could put any two variables in here, and we'll see that later on in another video, and get a different elasticity. If it means something, that's a different question, but we're going to focus on ones that are common. All right, again, especially at the introduction level. So let's try it out. Like I said, the math is not very difficult. So let's do what I would call the easy example. Okay, these example would be a can of pop or soda for you Americans is having a price decrease of 2%, and this results in a quantity demanded change of 5%. Okay, what is the elasticity? Right. I call this the easy one because it gives you all the information you need. So you really are just going to be plugging into the formula and seeing what you get. So a price decrease of 2%, right? That means negative 2% is going to be my percent change in P. Quantity demanded changes by 5%. Now, they didn't say positive 5, but I know that demand, quantity, and price move in opposite directions. So this is going to be plus 5%. And again, that will be my percent change QD. And then all we're going to do is plug them into our formula, right? So we've got elasticity of demand equals plus 5 on top. And I'm not even going to take away the percentage. I'm just going to leave them as whole numbers over negative 2, right? Which is going to be negative 2.5, right? Again, no units, okay? No units. Just 2.5, negative 2.5. Now, it's very hard to screw this up. Really the only way is you put the wrong thing in the wrong spot, and that would be just a minor human error, or maybe you just have the wrong formula. Don't do that, I guess, is my best advice. Now, in terms of weirdness, here's a weird thing for you. ED will always come out negative, right? Because remember, if price goes up, quantity goes down. That's a negative division. If price goes down, quantity goes up. That's going to divide into a negative number. So we will just take the absolute value and turn it positive, right? If you're not familiar, the term absolute value just means I'm going to put little bars on the side like this, and it magically changes it to 2.5 instead of negative 2.5. The reason we do this is purely convenience, all right? The negative 2.5 is fine, it's not wrong, but when we go to compare it, it can get a little tricky because then we have to remember that negative 3 is lower than negative 2.5 because it's on the negative side. It creates a lot of chance for silly mistakes. So by just turning it positive, we're going to make life a lot easier, all right? Now, I will say, we don't do this all the time. This is only for elasticity of demand. When we do supply, we won't touch it. When we do any of our specialty elasticities, we won't touch the sign. But this one, it's always negative, so we just don't care. All right, watch out for that. Next up, let's make it a little harder. Okay, little harder is not much harder, to be honest. Medium example. Okay, a can of pop, just stick on the same theme here, has an elasticity of 3. The price changes by, I don't know, plus 3%. What is the percent change in QD? And again, all we're doing here is basically giving you different parts, right? This is what, I don't know, I don't call it that, but it's a 3-part formula. You have 1, 2, 3 possible terms. As long as your instructor gives you 2 of them, you can find the 3rd, right? So if they give you QD and P, you can find ED. If you have ED and P, you can find QD, and etc. All right, so all I'm doing here is just giving you different pieces. So we say, okay, elasticity is 3. I don't know percent QD. That's what they're asking. But I know percent P is plus 3. So with some simple algebra, I'm going to take this, move it over here as a multiply, and I'm going to get 9 equals percent change QD. Again, not super hard to get right. However, this is actually wrong. Okay? And I'm going to explain why here quickly. Be careful when they give you elasticity. Okay? You got to be careful. Remember, I gave it to as 3 because that is convention, right? Giving you elasticity as a positive is normal convention. However, you need to be careful with your final result. Okay? What I mean by this is you have to check the sign. Okay? Technically, if you want to do this mathematically correct, what you should do is say, oh, elasticity is 3, so I have to remember to change that to -3 because it's demand, and then I'd put -3 here times +3, I'd get -9. That's fine. You can absolutely do that. I think an easier thing to do is just to say, okay, how about we get to the end, we just plug in the numbers as they are, we get to the end, and then at the end we do a quick check, okay? Price was going up, which means we know quantity for demand has to go down. They have to be opposite directions, right? So when I look at this and I see, oh, price went up by 3, quantity went up by 9, that can't be true, right? Violates law of demand. So I just manually at the end say, oh, well, I know price is positive for sure because they told me that. So let's just switch the sign and make demand negative. Okay, and then you come down and just throw a little negative sign on here just to remind yourself they should be opposite directions. Right, so remember, P and QD move in opposite directions. Right. Again, there's nothing wrong with using -3 right off the bat. Most people forget to do that. So I like to tell students, just do a little check at the end. Now the hard one, okay? The hard one is not necessarily hard, it just looks far more intimidating. So, hard example. A can of pop goes from $1 to, let's do $2 to be easy. This causes quantity to go from 100 to 90. What is elasticity? So you can hopefully tell right away. The big difference here is that instead of giving you the percentage changes, they are just giving you the raw numbers. Now be careful, and this is something you'll want to clarify with your own instructor if you are physically taking an economics course. One way to do this is you can just find percentage change using the normal percentage change formula. So the normal percentage change formula would be like P2 minus P1 over P1. And Q2 minus Q1 over Q1. Okay, that is our normal percentage change formula. However, that's not the way I'm going to show you, and the reason is it's not the way most people do it, especially in economics. In economics, we have a special tool for this. And it's called the midpoint formula. Okay. And what this is it's going to look at percentage change in a slightly different manner because it gives us a better representation of what the elasticity truly is. And it uses an averaging formula within the percent change formula. And again, it throws off a lot of students just because it looks scary, but it's really not that bad. All right. So we're just going to show you both pieces. So percent QD. Okay. We are going to have Q2 minus Q1, again, very similar, divided by Q2 plus Q1 divided by 2. And it's this bottom piece here why it's called the midpoint formula, because what I'm doing in the bottom is taking an average of Q2 and Q1 by adding them and dividing them by 2, and an average is a midpoint, right? And then for percent change P, well, the nice thing is all we're going to do is do the exact same thing, but with P's instead of Q's. P2 minus P1, P2 plus P1 over 2, and we're done. All right. Now, in the real thing, to get elasticity, we would then divide these two by each other, making a really tall formula. But I recommend to most students just solve them as they are. Okay, just solve them like this, do each piece, and then import them into the formula. So one thing to watch out for, and I've seen people make this mistake a lot, is make sure you call P1 and Q1 the same pair. What I mean by that is like $1 is where we started, so we'll call that P1. 100 is where we started for Q, so we'll call that Q1. If I had have called this Q1 and this P1, it wouldn't have worked. They have to do their matching pair. So P1, P2, Q1, Q2. Now, after that, it's just subbing things in. So Q2 minus Q1, well, that's 90 minus 100 all over 90 plus 100 over 2. Again, be careful just to do the bottom first, but we're going to get negative 10 over 95. I am not that smart, so what is that? 10 divided by 95 is 0.1053. Okay, keep as many decimals as your professor wants. I don't personally care, but some professors do. For price, well, its P2 is 2 minus 1 over 2 plus 1 over 2. So we're going to get 1 divided by 2 plus 1 is 3, divided by 2 is 1.5. And we're going to get, this is nice and easy, 0.6667. Right? My mental math is not the best in the world, so bear with me. Perfect. And then all we have to do is divide these two. But interpretation-wise, this number basically means our quantity changed, let's say not changed, our quantity lowered by 10.53%. Again, according to midpoint formula. Be careful. The answers are not going to come out to what you think they are, because a lot of people would look at this and be like, oh, it dropped by 10%. No, because we're using this midpoint formula. Okay, it's not your standard percentage change. Down here, we would do the same thing, but our price. So our price rose by 66.67%. Okay, again, according to midpoint formula. Right? And then all you do to wrap up is just divide the two, right? We go back to our roots and say, okay, well, in that case, ED is going to be negative 0.1053. Again, you could change them to whole numbers. There's no point, all right? Divided by 0.6667. Again, not that smart, so 0.1053 divided by 0.6667. 0.158, we'll say. Now again, we take the absolute, so it's 0.158. Okay. Quick thing I'll just add here. One thing I've seen professors do to try and make this easier, but sometimes actually complicates things, is they will give you a percentage change for one of them. Like they might just have given you this number here and then asked you to solve for this number and then do the elasticity. The only thing I warn people, make sure that the two numbers you're dividing, so the percent change QD and the percent change P, are in the same format. So if one's in a whole number, make sure the other one's in a whole number. If one's in its decimal percentage form, make sure the other one's in its decimal percentage form, right? Otherwise, you're going to get a really wacky number. In general, elasticities are usually between like -3 and +3. So if you get like positive a billion or positive like 50, that's probably not correct, and you might want to look into that. All right. That's pretty much all the math for elasticity you're going to need in most intro courses. Again, it's not overly complicated. It's especially nice if the professor gives you the formula so you don't have to memorize it. But even then, memorizing it isn't so bad. All right. I personally think this is one of the chapters, especially in an intro level course, where a lot of easy marks can be scored. So I encourage you to sit through the next couple of videos as we go through the other parts of elasticity, and hopefully that'll help you get some points on your next test. With that being said, thanks for stopping by. I'll see you next time. Bye-bye. Well, folks, that wraps up another lesson for today. I hope it was helpful. If you found the video valuable, please make sure to like and subscribe. And if you have any questions about the content or requests for other topics or subjects you'd like me to cover, please leave a comment below. Until next time, keep learning and make it easy.